So hello guys, today we are going to do a LeetCode question that goes by the name task scheduler. The question number is 621, okay, and it's a medium level question. It's a LeetCode daily problem, okay, and as I've seen on YouTube, like it is not much like in a clear way explained by the existing videos. It is not that much clearly explained, so I'm trying to just explain it in an easy way. I'm trying to explain it in an easy way so that everyone understands, okay. So it's kind of hard to understand what is exactly being done, okay. If you just see the code, you can't understand it. So let us try to read the problem statement, and let us try to analyze if we can explain it in a way that everybody here understands, okay. So as someone you are new to our channel, we just first try to read the problem statement and then we move on to the solution. That is the pattern that we follow, okay. And reading the problem statement can take any amount of time, okay. So videos can be long, but you would get quality content for sure, okay. So what you are given is, you are given an array of CPU tasks, each represented by letters from A to Z, okay. So what you are given is, let us first try to write what you are given. You are given a task array, okay, and what the person is saying, what the person that wrote the questions is saying, the contents can be from the letters from A to Z, from capital A to capital Z. It can contain only these letters, okay, and a cooling time n, okay. I'm given some cooling time n. Let us see what is this cooling time. We are still don't know how what is this cooling time is. We'll see, okay, we'll see. So what is this cooling time? Each cycle or interval allows the completion of one task. Okay, each cycle or interval allows the completion of one task. Task can be completed in any order, but there is a constraint. Identical tasks must be separated by at least n intervals due to cooling time. Return the minimum number of intervals required to complete all tasks. Okay, what the question is particularly saying is, what the question is trying to say, this is what we are given, okay. We are given an array that will consist of A to alphabets from A to Z, and these alphabets basically represent a task. So each of these are a task. Each of these are a task performed at particular cycles. So if I am at this position, this is a cycle. If I am in this position, this is a cycle. So this whole is a cycle. 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 So what the question is trying to say is, basically I can perform only one operation in one cycle. One operation in one cycle. Okay. One operation in one cycle. Okay. And we can perform the operations in any order. Perform the operations in any order, okay. So it doesn't matter whether I perform the C first or B first or A first, anything first, okay. So we can do only one operation in one cycle, and we can perform the operations in any order, but there is a constraint given to us. What is the constraint? If we try to analyze what is the constraint, same task same task require n cooling time. What does it mean? What does it mean by require n cooling time? Okay, n cooling time. So basically if you are given with this task, suppose you are performing these tasks, okay, you are performing these tasks a b, basically a b c a b c, okay, and here my cooling time is 2. Okay, so what does it mean by that is, basically the letters represented by the same digit, by the same character, represent my same task, okay, same task. So it requires n equal to cooling time. That means for two cycles the same task should not occur. For two cycles the same task should not occur. Why? Because each one of these is a cycle, okay. This is one cycle and this is one cycle. Why is it a cooling time required? Basically, suppose you are playing some games like COD, okay. So if you are playing this, okay, so if you are trying to do this again, like playing this for a long time and you then stop it, and your phone requires some cooling time, right? For cooling time, right? Because it is doing the same operation again and again, And if you tell it to do the same operation again, if you just close this operation and try to tell it that you just close the game and then just open it, okay, so it will require some time to open. It will require some time to open. It will just open slowly instead of like opening very fast, because the processes that are involved in the particular thing require some time to cool down. Require some time to cool down. Okay, require some time to cool down. So this is my cooling time. Basically, from this B to C would be my cooling time from A, and from this index my A can occur. From this index my A can occur, and it can occur anywhere. A can occur here, A can occur here, A can occur here. Anywhere it can occur. Okay, but what we have to do is we cannot place it anywhere, right? We have a constraint: return the minimum number of intervals required to complete all tasks. We have to complete all tasks. Okay, so if there is one more A, I have to place it so optimally. If I have to place it so optimally that I have to place it so optimally that it requires the minimum number of cycles. That it requires the minimum number of cycles. Okay, okay, minimum number of cycles. Okay, so if I just tell you, try to tell you, explain you the question by test case. Okay, if you are given this test case A, B, 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 and n is equal to 2. So we're given like this: A, B, 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 and n is a cooling time. Just remember that same elements only require the cooling time. Okay, because if you are telling one person, if you are telling one person to do the multiplication operation, this person is doing the addition operation, this person is doing something else. Okay, so if you are saying this person again to do the multiplication operation, then it will require some time because it is exhausted, right? It is exhausted. It is exhausted. So it will require some time to cool down. But if I give other operation, if I give the addition operation to this person is already cooled down. This person is already cooled down, so it can perform the operation very easily. It can perform the operation very easily. Okay, okay, very easily. Okay, so we'll try to analyze how we can place them such that it requires the minimum number of time. Minimum time. Okay, and what if you can't place anything on that position? What if you can't place anything on that position, any other element on that position? Just see that you will be placing an idle on that. Basically your computer, your PC cannot do, your CPU cannot do any work at that time, so it will be left idle. Because if all the components are cooling at that time, if all the components still require some time to cool down, none of the operations can be performed. None of the operations can be performed. Okay, so let us see. Basically, if I given like this: a b b b, a b b b, okay, and I'm given something like this. I have to arrange it such that the time is minimum. Okay, the cycles are minimum. The cycles are minimum. Okay, so what I'll try to do is I'll try to put the first A. Okay, A. Okay, then what I can do is, can I put the A again? Suppose this is my first zeroth cycle. Okay, can I put the A again? No, no. Okay, so what can I put? Can I put this A? No. Can I put this B? Yes. Okay, so I can put this B, and it will be at the index 1. Okay, just remember that this B is used, this B is used. So now can I put any of this again? Can I put this A? Can I put this A? Or can I put this B? Or can I put this B? Or can I put this A? No, no. So what I'll say is I can not do anything, so my CPU would remain idle at this place. Okay, now for this end, this becomes true. For the third index, can I place any of these? Like I have the options of A or B only, right? In this array, in this array, I have the option of only A and B. Okay, so can A or B be placed here? Can A or B be placed here? Just remember my n is equal to 2 for this case. N is equal to 2 for this case. Okay. So every process would require a cooling time of 2. Would require a cooling time of 2. But if you just observe, my A was at first performed at index 0. My A was first performed at index 0, and it has gone through a cooling time of 2, and it has gone through a cooling time of 2. So I can easily put my A here because it has already been cooled. I can put my A here. Okay. Okay. So this A will also be used. Now comes my 4 index. What can I put? Can I put my A here? No. Can I put my B here? Has the previous B has gone through a cooling time of 2? Let us see. My previous B was here. Cooling time is from here to here. Is it equal to 2? Yes. So I can put my B here. I can put my B here. Okay. 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 I'll just come to the index 5. I'll just come to the index 5. So can I put my A here? Can I put my A here? Okay. My last index of last occurrence of A was here. Has it gone through a cooling time of 2? No. Okay. My previous occurrence of B was here. Has it gone through a cooling time of 2? No. So I cannot put any of this. So it would be idle. Okay. I'll just move forward. I'll come to the sixth index. Sixth index. Can I put any of these, A or B? Okay. My A's previous occurrence was here. Has it gone through a cooling time of 2? Yes. Okay. Yes. It has gone through a cooling time of 2. So can I put my A here? Yes. Okay. If you have put an index, if you have put a character, you will just stop. Okay. You'll just stop. Okay. I'll just move to the next index, 7. Can I put my A here? No. A has just came. Okay. Can I put my B here? Okay. My B was here. Has it gone through a cooling time of 2? Yes. Okay. So can I put my B here? Yes. Okay. Okay. I shall go to the 8th index. Oh. Shall I go to the 8th index? No. No. Because as you can see, this A, this B, this contains one A, second A, third A. So A is occurring 3 times and B is occurring 3 times. And in my previous array also, A was occurring 3 times and B is occurring 3 times. So all of this is used. So I cannot use it again. So here comes when my iteration stops. My iteration stops here. Okay. So this is my answer. And what I have to return? I have to return the size of it. So what is the size? Basically, I am going till index 7. So how many elements would it require? 7 plus 1, because we are following 0-based indexing. So 8. Is 8 my answer? Yes. Yes, exactly. And if you see, you will get the same as your answer. Okay. Okay. If I just try to show you one more test case, because you should be clear in mind what you have to do. Okay. Question should be clear. I'm not telling you the approach. Okay. I'm just explaining you the question till now, because it's a very complex question for beginners to understand. Okay. It cannot be understood very easily. And what I have seen is people are just explaining the basic, people are not even understanding what the question is about. Okay. So I'm trying to explain it to you. Okay. So let me just take my second test case, ACA BDB. Okay. ACA BDB. Okay. I'll come to this. This is my array. Okay. And I'll jot down all my frequencies. A is occurring 2 times, B is occurring 2 times, C is occurring 1 time, D is occurring 1 time. Okay. So if I try to start from A, okay, I'll just start from the map. Okay. I'll first try to write down A. Can I put my A at the 0th index? Yes, because it is the first value to be put. I can put it. I'll come to the first index. Okay, my cooling time is 1 here. Okay, 1 here. Okay, that doesn't mean that this is the place. It requires for cooldown. Okay, so my A cannot be put here. Okay, if my A cannot be put here, what is the next element that can be put here? B, or any other element. I'm just traversing the map. So for your convenience, okay, I can put C here also. I can put C, okay, but I'm just traversing the map, so it becomes a little more logical. I have used the A, so I'll not use it again, because if I have used the C, if it will still requires a cooling time. If I come across C again, or if I come through B and it requires a cooling time, I come through B again, so I have to mark it again and again. I have to mark it again and again. Okay, so what if I just traverse? What if I just traverse the map, because it contains the element only one time? Okay, so can I just store my B in this place? Yes, because B is not occurring, so B can be stored. Okay, I come at my second index. Okay, so so I'll just traverse my map again. From the start. Okay, can A be stored here? Remember, my A's frequency is reduced to 1, B's frequency is reduced to 1, because it is used. Okay, Okay, so can I put my A here? A has the frequency. Does A has the frequency to be stored? Yes. And is A cooled? Yes, because it has a cooling time of 1. A was previously here and it has gone through a cooling time of 1. So yes, A can be stored here, and its frequency becomes 0. Okay, I'll come to the third index. Okay, so I'll traverse the map again. Is A having a frequency of greater than 0? No. So A can be dispersed from this. Okay, I'll now start from B always. So has B has the frequency of greater than 0? Yes. Has B gone through a cooling time? Yes. B was previously here and it has gone through cooling time of 1. So it has gone through cooling time of 1. So B can be stored here. Okay. So the frequency also reduces to 0. And it has gone through a frequency of 0. So I just remove it from the map. Now I am left with C and D. I'll come to the index 4. Okay. Now what I have to see is C occurring any of the time? No. I can easily store it. Okay. I'll come to the 5th index. As it has become 0, I'll just remove it. I'll come to D. Can I store D? Yes, I can store D. So this is what is my answer. Okay, and my last index was 5. So 5 plus 1 is equal to 6. Is 6 my answer? What do you think? Are we guys correct? Obviously we are correct. Okay. So now let us come to the approach. Okay, I'll just try to explain you the approach. Okay, how we can solve this. Suppose we have this. I'm taking the first test case again to explain you the approach, how we can solve this. My n is equal to n is my cooling time. Okay, I hope you guys have understood the problem right now. By now I will tell you the approach how to solve it. Okay, suppose this is the array that you are having. Okay, so as I just saw in the previous question, we were making a map. So that we know that how many elements are used, which of the elements are used. Okay, so we'll do the same here. We'll just make a map. My map would contain A is equal to 3, B is equal to 3, Okay. So do you think can we randomly put any of the elements? Or if we put in a more serialized order or following a pattern, we can arrive to the solution. I'll just tell you. Okay. So what you have to store is, suppose basically there is no cooling time. Okay, suppose the cooling time is 0. Okay, so how many places would you require to store all of these elements? Okay, cooling time 0 means A and A can occur together, B and B can occur together, and A can again occur together. So this frequency, the overall frequency now becomes 0 of all the elements. So what you can say is, if my cooling time is equal to 0, okay, it would require exactly 6 space, and that is equal to the space that was given, because this remains as my answer, right? There is no cooling time. I can provide I can throw any task at the CPU, it will perform it. I can throw any task at the CPU, it will perform it. Okay. This is an ideal case. This doesn't happen in reality. Okay. Okay. So this is the case. This is the case when my n is 0. When my n is 0. Suppose my n is equal to 1. N is equal to 1. Okay. So when do you think? Okay. So for when n was 0, I was requiring a space 6. I was requiring a space 6. Okay. So what do you think? What element do we take that it just acquires the maximum space? It acquires the maximum space. We'll first pick up an element and we will assume that it is acquiring the maximum space. It is acquiring the maximum space. Okay. So I'll just pick up the element with the maximum frequency. I'll just pick up the element with the maximum frequency. What is the intuition behind picking up the maximum element? Because see, if I put up the maximum frequencies at first, there would be maximum number of gaps in between. Maximum number of gaps in between. Okay, maximum number of gaps in between. Okay, all of my elements can be contained here. Basically, if I let this follow, if I let these follow the condition that is given to us, basically it all has a given time. It all has a cooling time of 1. It all has a cooling time of 1. So taking the maximum frequencies tells us what is the maximum size that we will require. Because if n is equal to 0, we will require a maximum size of n. That is the task size array that was given to us. If n is equal to 0, that would be my answer in any case, no matter how many elements I throw it. Okay. So if my array is like this, okay, and my n is equal to 1, I'll just first write the frequencies. A occurs 3 times, B occurs 3 times, okay, B occurs 3 times, okay. So if I just jot down my frequencies, I just jot down my maximum frequencies, okay. So this is close to the maximum number that I require. This is close to the maximum number that I require for my answer. Because it will be including all the spaces. Okay, suppose you have this option, like if 1b was there, okay, or like 2b's were there, and I put the b's first, okay, okay. So these a's can occur anywhere, like a can occur here, a can then occur here, a can then occur here. So I cannot get a fixed size. Like this size would also not be fixed, but this would be the maximum that I can get close to. If I take the minimum frequency else of the maximum frequency, then I cannot get close to what I require. Okay. So if I take this and it is a n of 1, okay, it has a space of 1 in between. Okay. So now I have filled all this A. So my A's frequency would be 0. Now I have to fill all of these B's, and in one space only one B can occur. Why? Because it requires a cooling time of at least one. So this is the cooling time, and next B would occur here. Okay. But what about this? Like this, the frequency becomes 1. The remaining frequency becomes 1. So what about this one? As I've already filled all the spaces, what about this one? Yes, it would simply be stored here. Okay. Okay. But if you see closely, this is the size of my array. That I was given with. Okay. So if I don't have any idle conditions in between, okay, I can basically arrange them in an order. Okay, such that it will require the same space. As required by my task array. Okay. Basically, if if I can store it in such a way, if I can store it in such a way such that I don't require any of the idle places, such that I don't require any of the idle places. So this can be arranged in a way, this can be arranged in a way, okay, this can be arranged in this way, like A can be arranged in this way, A can be arranged in this way, if n is equal to 1. So the size would be same, size would be same, as no idle elements would be required. Idle elements would be required. No idle elements would be required. No idle elements would be required. Okay, suppose my same case has a cooling time of 2. Same case has a cooling time of 2. Okay, so what I have to first do is I have to just jot down my frequencies. My frequencies are b is equal to a is equal to 3 and b is equal to 3. Okay, so what I'll do first, I'll take the element with the maximum frequencies, and this I will continue. I'll again take up the maximum frequency and again. So I have to take the frequencies in the max to min order, basically in the decreasing order. I have to take the maximum frequency and the next maximum and the next maximum and the next maximum and the next maximum, and the list goes on. Okay, so I have to take a in this case. I'll just put a, I'll just put a, I'll just put a. Okay, and how many spaces are there in between? How many spaces are there in between? Basically two spaces are there, two spaces are there, and in this two spaces are there, two spaces are there. So if you closely observe one more thing, if for three elements I will make two partitions, I'll make two partitions. How two partitions? Basically one partition would be this and one partition would be this. So, and if I try for four elements, for four elements, okay, one partition would be here, one partition would be here, one partition would be here. Okay, so this cycle goes on, this cycle goes on. Okay, this cycle goes on. So for n numbers, for n numbers, I would be creating n minus 1 partitions. I would be creating n minus 1 partitions. Okay, and all of the remaining element, out of all of the remaining elements, only one element of the say of each type can be placed in this. Basically, I can put only one B in this partition. I can put only one B in this partition. I cannot put any other B in this partition. I cannot put any other B in this partition because it requires a cooling time of 2, and my cooling time can only be fulfilled when I put it in the second partition. Okay. Basically. Okay. I'll first jot down my frequencies. I am given something like this. I have a cooling time of 2 in between. I don't know whether it is idle or not. Okay, but now I know that for n numbers I will be getting n minus 1 partitions. That means for every other element, like this is used in the first case. So for every other element, I can either fill this number or I can fill this. I can fill, maximum that I can fill is this. Maximum that I can fill is this. Okay, n minus 1 are the maximum numbers I can fill. Okay, maximum numbers that I can fill. Okay. I don't have any other choice. I'm not considering the choice like elements would be placed, or no, I'm not considering it. Okay, I'll eventually get the answer. Don't worry about that. So if I have three B's initially, okay, let us suppose that these A's are like eliminated, and I'm left with B's, okay. So as you know, in this partition only one B can be placed, okay, and in this partition one B can be placed, okay. So can I place this B in this partition again? No, no. Why? Because if I place this B in this partition, because I already have a B, and if I place this B in this partition, I would be contradicting. The cooling time. So as we move forward, I'll just store the minimum of frequency of the current character or the frequency of the partitions or the number of partitions. Okay, because the number of partitions is the maximum that element can be reduced. Okay, basically if 3 elements are there, I can still reduce it by 2. If 5 elements are there, I can still reduce it by 2. If 100 elements are there, I can still reduce it by 2. I cannot reduce it by any other number. But we have a surety that it cannot be greater than the maximum element. It cannot be greater than the maximum element. It cannot be greater than 3. Why? Because if it was greater than 3, if it was greater than 3, if it was greater than the maximum element, it would be the maximum element by itself. Okay, suppose if I have a and b. Okay, and if you say that I'll select this, okay, I'll select this, and I say that b has a frequency of 4. If b has a frequency of 4, what was the first rule? That we have to take the maximum frequency, right? Why didn't you take the maximum frequency at first? If you're doing the first step wrong, you cannot get the answer right? So I cannot do this step. I cannot do this step. If my b's frequency is greater, I'll first put all the b's, and then I'll put the a's. Okay. For this case, as I have 3 partitions and I have 3 elements, I can put all of my elements in one position. So a would be here, a would be here, a would be here. Okay, and this element would be remain empty. This elements would remain empty. Okay, so these are the elements. That are contributing to a size increase. These are the elements that are contributing to a size increase, because these are the elements that are helping us to maintain a partition, to maintain a cooling time. Okay, so this and this are the elements that are helping us maintain the cooling time. Okay, so I cannot fill them. Basically, okay, you just don't have to put the elements also here. Okay, you don't have to put the elements. What I mean by this, basically, if I'm given with this, now I know the frequency that a has 3, b has 3. Okay, I put my maximum here, a and a. I know that my n is 2. Okay, so I'll assume that all of these places like this 2 and this 2 are filled by idols. I fill by idle elements only. I fill by idle. This is idle, this is idle, this is idle, and this is idle. Okay, I'll assume that all of them are filled by idle. Okay, for my convenience, I'll assume. Okay, so I know out of all these elements in one pass, how much idle can be reduced, how much the value of idle can be reduced. It can be reduced by like either the partitions, the number of partitions, or the frequency of that particular element, because if I have 2 partitions and I have 3 b's, still only 2 b's can be filled. I cannot put more than 1 b in one partition, so only 2 b's can be filled. Okay, so if I have 4 idols at the start, I come at b and I see what is my partition size. My partition size is 2 and my frequency is 3. Okay, my partition size is 2, my frequency is 3. Okay, so what I'll reduce at this pass? I'll reduce the minimum of both of them. So what I'll do is 4 minus 2 becomes 2. Okay, that means there are still 2 idle places, and that is true because 1b would be placed here, and 1b would be placed here, but these 2 places would still remain idle. They cannot be filled by the same element. If I have any c, then c can be placed here, but as of now we don't have any c. Okay, so these 2 places would remain vacant. So what would be the size that I would return? What would be the size for this case that I would return? Yes, it would be this size. Okay, and how can I calculate this size? Basically the number of idols remaining after filling all the required idols. So this task size, the element, the array that we were given at the start, this task size plus the idols that are remaining. Okay, because these idols cannot be filled. and if they cannot be filled, they are still there to maintain the cooling time. They cannot be removed, but they have to be there to maintain the cooling time. So they will be the only one that will be increasing our size, because as we saw, if we have a n is equal to 0, our answer would be only task of size. That is the array size that is given to us. Okay, the extra element size is only from the idols. Okay, only from the idols. So for this case, my idols are remaining 2. So what is my task size? Task size is 6. And the number of idols remaining is 2. So answer would be 8 for this case. And boom. Yes, this is our answer. As you can see, 8 is our answer. Okay. What we are doing is, I'll just try to summarize what we are doing. Summary. Okay. What I'll get is, first I'll take the maximum frequency, or I'll get the frequency of each of the character. I'll get the frequency of each character. After getting the frequency of each character, I'll sort them in decreasing order. So that I get the maximum frequencies at the first decreasing order. So I get maximum frequencies at first. Okay, Okay, then what I'll do is, I'll get the so now I'll calculate the number of idols. And these number of idols are what? Number of partitions into the cooling time. How? If you just try to observe, if there are 3 n's to be placed here and the n is 2, 3 a's to be placed here, n is 2, it is creating 2 partitions. And each partition would be having 2 elements. So if one element is having 2 partitions, n element will be having, basically m element will be having n into m partitions. Okay, so 2 partitions would be having 2 elements each. So 4 would be my answer in this case. So it would be like the frequency of the maximum character, because we are considering the maximum, minus 1, because for 3 elements only 2 partitions are created. Same for 3 elements. For 4 elements, 3 partitions would be created. It would be like n minus 1 into n. So it will give me the number of idols. I'll suppose each of the empty space is an idle as of now. Okay. Each of the empty space is idle as of now. Okay, and when I calculate my idle, I will traverse all the remaining characters and at each step, what would be subtracted from idle? What I can subtract from idle at each step? I can only subtract the minimum of the character's frequency of the character, or my partition size, because suppose that we saw that actually, okay, we saw that if we having 5 elements, but still I have my partition size as 2, I'll have to reduce only 2 elements. These 3 elements would remain. They cannot be stored here. If my b is here and my cooling time is 2, I cannot store my b here. Okay, so that b would remain. It won't give us any problem, because this idle time is the one that is just increasing our size. Okay, if this idle time was not there, my b would be stored here. Okay, so this idle time with the task size can give me my answer. Okay, so what is my fifth step? I'll do this at each step. And after traversal, what I'll return? task dot size plus maximum of 0 comma idles that are remaining, idles that are remaining. How remaining? That basically subtracting, we are subtracting at each step, right? So the number that is remaining, or zero. Basically, if we are reducing at each step, okay. So we are reducing for 4 at each step, 3, then 3, then 3, then 3. So it can become negative. Okay. So I wouldn't take the negative. In this case, my 0 would be added. So task dot size will be the enough array, will be enough in that case. When my idle will be 0. In that case, when my idle is equal to 0. Okay. So if I just show you all the steps, get the frequency of each the character, sort them in decreasing order, okay. Get the number of idles at each step, do this step, okay. Frequency of max minus 1 into n, okay. Why? Because the number of partitions into numbers at each partition, number of partitions into number of blank spaces at each partition. So this would give me the total number of idles, and at each step what I'll subtract is basically the minimum number of elements that I can do. 5 elements, 2 partitions, still 2 would be subtracted, okay. If the number of elements are less, suppose basically 2 partitions are there, but I have only one element, so only one element would be subtracted, right? I cannot fill them by the element that is not at all present, okay. So, and at the last, all the idles that would be remaining, I'll just simply add it to my task dot size. Why? Because just we saw, if n is equal to 0, my answer would be task dot size, okay. So if these idles remain, okay, then it would be added, because this is the one that is maintaining our cooling time, okay. Else it would be added with 0. Okay. Let's try our second test case. ACA BDB. And n is equal to 1. Okay. N equal to 1. What I'll first do is, I'll just jot down all my frequencies. That was the first step. A is occurring 2 times, B is occurring 2 times, C is occurring 1 time, D is occurring 1 time. Okay, D is occurring 1 time. What I'll do is, I'll choose the maximum frequency first. I can choose any of this. I'll choose A for the first. Okay. So I'll choose A for my convenience. So A would be written 2 times. So as n elements are there, only one partition would be created. And what is the size of that partition? Only one element. Okay, so my A is fully used. I'll continue from B. There are 2 elements. Okay, first I'll get the idle size. Idle size is equal to the number of partitions, that is 1, into size of each partition, that is also 1. So 1 is my idle element. That is true. Okay, that is true. Okay. I'll come to the B. Okay, I'll try to reduce my idle with the minimum of the frequency or the number of partitions. Okay, so in this case, my idle is 1 and minimum of 2 comma 1. Why? Because the partition is only 1. Be the elements with 2, but it can be reduced by only 1. So 1 minus 1 is equal to 0. My B would be stored here. Okay. So my idle has become 0. Elements would still be getting reduced, like 1 would still be reduced, 0 minus 1, this one would still be reduced, so it becomes minus 2. But when I come to my final answer, I'll just see that as n is equal to 1, in this case, my idle has become negative. But idle cannot be negative because it denotes spaces, the number of spaces. So it will be just saturated 0. It will be moved to 0. From negative, it will be moved to 0. Okay. So what I have to return at the last? I'll have to return the task dot size. plus max of 0 comma idles. 0 comma idles. Okay, and it is true because if I store my B here, I require a cooling time of 2. My B can be stored here. Okay, and C and D can be stored here. Okay, so what is its size? 1, 2, 3, 4, 5, 6. 6 is this answer size, and what was my array data size was given? 1, 2, 3, 4, 5, 6. So 6. The size is matching. Sure. Okay, you get your answer. You get your answer. Just enjoy. So, shall I try this test case also? Shall I try this test case? A, B, 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 and N is equal to 3. Okay. And N is equal to 3. What I'll first do is, I'll just jot down all my frequencies. A occurs 3 times, B occurs 3 times. What is my first step? Writing all the maximum numbers. Okay. So this is fully consumed, and each of my partition would contain 3 spaces. This 3. Okay, I'll calculate the number of idles. How can I calculate the number of idles? Number of partitions into n. Number of partitions. How many number of partitions there? 1 and 2. So 2 into 3. Yes, 6 is my answer. 6 are the number of idles that I have. 6 are the number of idles that I have. So I'll come to B to 3. B and 3. Okay. 6 minus minimum of number of partitions or the frequency. So 6 minus 2 would be done. It would be 4. Why? Because 1B can be stored here, and 1B can be stored here. Okay, other B cannot be stored here, so idle places would remain as I. Okay, so in these 4 places, these 4 places are to be needed. 4 places are needed for me to get the answer. So okay, so as 6 is my space that I require, and I would require additional 4 spaces. So 10 is my answer for this case. Basically, task.size plus max of 0 comma idles. Okay, max of 0 comma idles. Okay, now only what element remains? A is filled, B is filled. Okay, and what is my size as of now? 4 and 9. Okay, 9 elements are still there. I'll place my B here. It will become 10. Okay, so maximum of 0 comma idles. These idles are still to be in place. They will not be removed. This are the only reason my size is increasing. So 6 plus 4 equal to 10. And boom. So this was the overall solution. Okay, now I'll try to code it. So what I require first, I require the frequency array, and I want its size to be 26 because I will be storing all the characters frequency. I'll just move through my task array, and while traversing, I'll make sure that I store each of the elements frequency. Okay, my first step is done. To get the frequencies. My first step is done. Now my second step is to get the maximum frequency. What I'll do is I'll just sort the frequency array in decreasing order. Why decreasing order? I can easily get my answer at the 0th index. So I have done the second step. I have gotten the maximum frequency. Okay, now what I'll do is calculate the number of idles. Calculate the number of partitions. Basically, first I'll calculate the partitions. So how many partitions would be there? Partitions would be exactly equal to frequency of 0 minus 1. Because frequency of 0 means my maximum frequency, and my maximum frequency minus 1 would give me the number of partitions. Okay, and how many idles would be there? This partitions into size of each partition. So partition n. Okay, this is my answer. Okay, now what I'll have to do is now I have the partitions, I have the number of idles. Okay, I am calculating. Calculate the number of idles. Okay, calculate the number of idles. Okay, and what I'll do is I'll just start from the first index. I'll just start from the first index. Why first index? Because we have already taken the 0th index. Okay, and I'll go to the frequency. I'll go to the frequency I plus plus. Okay, and at each step I'll just reduce my idles by the value minimum of frequency of I, comma the partition size, okay, comma the partition size, okay. This is what my number will be reduced by at every step. And what I'll have to return the task size plus maximum of 0 comma idles, okay. In this step I'll just reducing my idles by the minimum frequency, okay. And at this step what I'm doing is adding the number of the adding the size of the given array with the idles that are required. I'll just try to run it. Let us see. Okay, it has run successfully. I'll try to submit. Okay, submitted successfully. Okay, so if I just try to summarize, I just wrote the code with you, and I just written all the comments also. So this is what we are doing. First we are trying to get the frequencies, then we'll try to get the maximum frequency, then I'll try to get the number of partitions, because the number of partitions into n would give me the number of idles. I'll consider that every step, every empty index is my idle, so I'll try to fill the number of elements, that are remaining, because at each element only one occurrence of a particular character can be there. Okay, so if B is coming in one partition, this partition cannot have one more B. Okay, so that's why I'm just decreasing by minimum of frequency of partitions. Frequency of I, if my B is 5 but my partitions are 2 or 3, so it will be reduced by 2 or 3 only. It cannot be reduced by 5. Okay, and what I'll do is, what I'll return at last is, I'll simply return my task.size plus maximum of 0 comma idles. Basically what this line means is, task.size is when my n was 0, when there is no cooling time required, plus idles is for the cooling time that is required, so the additional space that I would require. So if I try to consider time complexity, my sorting takes O of NLogN, and else I'll just traversing, so n. Okay, this is my time complexity, and what is my space complexity? As I'm using an extra space, so O of n is my space complexity. Okay, so this was the overall solution to the question task scheduler. If you have any doubts, I have tried my best to explain the solution. Okay, I've just written down all the comments. If you don't yet understand it, you can watch the video again. Maybe you will understand it. Okay, if you have any suggestions, any comments, any doubts, you can ping it down in the comments. If you like the video, do like, share, subscribe. Thank you. Have a nice day. Bye bye.